Hello all, today in this video we are going to make a continuation of the previous ANN video only, but previously we have worked with Adam optimizer and SGD optimizer. In this code we are going to work with RMSprop optimizer. So here if for that initially we are just importing the libraries which we are needed, then we are just loading our data set. This data set we downloaded from Kaggle. You can just give us heart disease prediction Kaggle means you will just get this link, and it is having nearly 14 entries. Among that the first 13 entry we will be using as the x variable, and the last variable, that is the target variable, we will choosing as the y variable. And then we are getting the info of the data set. From that you may get that every variables or integers, only the old peak variable is the float one, and then we are making the description of the data set, and then we are just checking whether our data set is having null values, because if it is having any null values means we have to work with some pre-processing functions. Then we are making the heat map of the data set. So this is the heat map of the data set which is having nearly 14 entries. Then we are splitting the x variable and y variable. As I said previously, the first 13 columns we will be using as the x variable. For that we are omitting the last column, and in the y variable the only the last column is chosen. Then based on this x variable and y variable, and by using the train test split function, and the test size is 0.2, that is 20% for testing and remaining 80% for training, we are determining the variables like x train, x test, y train and y test. And then we are using the standard scalar function to just make the pre-processing function, that is to convert vectors for the variables x train and x test. Then we are getting the train of x train, the shape of x train variable. Why? Because this shape we will be using as an input for the first layer in artificial neural network, that is ANN. Then we are just determining our layers. First is the sequential layer, next comes the dense layer with added by 2. Totally there will be 3 dense layer. In the first dense layer we will be having the output dimension as 11, kernel initializer as uniform, activation as ReLU. This the four things will be common for all the dense layer, but in the last dense layer the activation will be sigmoid. In the first dense layer we will also be adding the input dimension, which is 13, which this 13 is the from the x train shape. The why here we are given 1 because our classification is a binary classification work. Mostly in binary classification work we will give the output dimension as 1 only. If it is a multi-class classification means, for example, if it is 3 means, here we will be giving us 3, or 4 means 4, but binary means we will giving us 1 only. Then we are compiling here by using the Adam optimizer, loss as binary cross entropy and metrics as accuracy. We are also declaring an early stopping. Here we have given the patience as 10. Why? Because it will be taking a look for 10 approaches. So in the 10 approaches, if it is not showing not much difference means it will just stop at that point. Previously we give the 3 only. At that time we are not able to plot the graphs as a it is now as viewable, so only we just change the patience. Then we are using the fit function for training by using the x train, y train validation data, and approaches here we have given as 50. With the Adam it is not much showing very difference within the loss variable. Why I'm saying loss variable? Because in the early stopping we are monitoring the loss variable only. If you want to monitor validation accuracy means, you can just give that variable over here, or that parameter over here. Then we have got an accuracy of 91% for heart disease detection with the Adam. Then we are making a definition for confusion matrix plot, and we have made the confusion matrix for Adam optimizer. Then we have worked with the SGD optimizer, same as previous only, the layers description. The only difference is the optimizer. Then the classifiers, fitting and compiling is also same only. Previously, since we have given the early stopping as 3. It is just stopped for 4 approaches, but now we gave like 10. So it has stopped for 11 approaches, you may notice. So in the 11 approaches also it is not showing much difference, and the accuracy is 48% only. Previously, if you notice, means it is 90%. Why? Because we made some issues. What is here we have called the classifier as classifier yes, and previously here it is classifier only. So we just forgot to can make it name and give classifier only. So only it got 90. It is a mistake. So with SGD we are not getting the as same accuracy as with Adam. We are getting some less accuracy only. Then we are moving with the confusion matrix plot. Then we are making the definition for the RMSprop optimizer. Here also the layer description are same only. The only difference you may notice is the optimizer, which is RMSprop. Here we have given the name as RR. So kindly notice, if we have given the same name, if you are calling the name as R, means you are calling the name R in every occurrences. You just notice here the early stopping is not done until 50 approaches we are getting, and here the accuracy is 91 as same in Adam. So Adam and RMS prop is not showing much big difference. So this is the confusion matrix. Then we are making a comparison of the plot of a validation accuracy, validation loss and loss by using a graph. Here you may notice that with Adam only we have got the better accuracy, and when compared to Adam, this prop is also providing some best accuracy, but more or less everything provides the same only, not much difference. So loss is also same only, you may notice. So this is the details of this ANN algorithm. In the next video we will be working with some other optimizer. Thank you.